Hello, everyone, and welcome to the third part in this Urban Forestry Education webinar series. Funding for this project is provided by New York State's Environmental Protection Fund and is administered by the Urban and Community Forest Program in DC's Lands and Forests. Today's presentation is titled The ARC, Lifecycle Planning for Trees, presented by Mike Galvin, RCA, Director of Save a Tree Consulting Group. The presentation will start with planning for places where trees can be planted and where existing trees can grow, using the Los Angeles City and County Tree Canopy Assessment as a case study. We then look at maximizing tree service life at the site level with tools like the airspeed and tree radar and concepts like critical root zone and structural root zone in preservation planning. Finally, we'll look at opportunities to sequester carbon and reuse recycled wood in trees and buildings that are removed using the Baltimore Wood Project as a case study. Mike is director of the Save a Tree Consulting Group. He has over 30 years of experience in arboriculture in the public, NGO, and private sectors. He's a past president of the American Society of Consulting Arborists, served as a member of the Chesapeake Bay's program's Urban Tree Canopy Expert Panel, and received the 2011 True Professionals of Arboriculture Award from ISA and the 2004 Pat Felix Volunteer Award from the TCIA. His consulting assignments include serving as a project coordinator for U.S. Forest Service Research and Development's Baltimore Urban Field Station, where he works on urban wood recovery and reuse. All right, and Mike, I'll let you take it from there.
Thanks, Kevin, and thanks, everybody. Good afternoon. Thanks for taking the time out. We're going to look through some material here and then hopefully have some time for question and discussion at the end. I'd like to start with some things we've learned over time. I've been doing this for a while, longer than I care to admit, and a few things we've learned about some of the tools we've worked with. Tree canopy assessments are great tools for big picture assessment of where canopy is and where canopy can be. But tree management decisions are made at the parcel scale, so you've got a lot of individual decisions that have to scale up when you're talking about tree canopy planning at the city scale. And of course, nobody controls all of those individual decisions. The tree you have now can do more than the tree you will plant in its place, so preservation is a better, more efficient way to go. As far as tree benefits, tree canopy is normally a process, but tree canopy loss is usually an event. So gain is very incremental year after year as trees grow. When a lot is cleared for development, that's a lot of canopy relatively that you lose at one time. Trees sequester carbon and can have use beyond landscape service life, and we'll talk about that. If you cut down a tree and you take that tree and you make it into a table or a guitar or a chair or some type of piece of furniture, you bind up that carbon for the service life of that thing you make. If the tree decays or you burn it or you chip it and it degrades, you release that in a much quicker time scale back into the system. So let's first talk about assessing where are trees and where can there be more trees. I've had the fortunate opportunity to work for years with some really talented people. Dr. Morgan Grove with the U.S. Forest Service Baltimore Field Station. He's a team leader for Forest Service research in that location. Jarlath O'Neill Dunn, he's the director of the University of Vermont Spatial Analysis Lab. And Dexter Locke, when we began our work together, he was a student. He is now also a scientist with the U.S. Forest Service Research and Development at the Baltimore Field Station. And so when we can capture imagery, high resolution imagery of a geography, we can see where the trees are. But if this were data instead of a picture, it would help us know how much tree cover there was in this location. So there's a technique that's been around for a long time that looks at the spectral signature of vegetation, which is unique. If you look at the difference between the red and near infrared bands of color, you can extract the things that have chlorophyll in them, the vegetation, pretty easily from an image. And so this is an image showing that technique used to classify all the vegetation in the image. So that's really good. But when we get into cities that have some vertical structure, trees can hide in the shadows and they can be more difficult to find. So through LiDAR, which is an aerial platform that shoots a laser down and it hits the top of an object and the bottom of the object, and the difference between the two returns tells you the height of the object, then we can take the same place and we can look at the height of objects, and you can see this image is the same geography we just looked at, but it's classified by the height of the objects in it. And so when we take the image and the LiDAR data and we fuse them together, we can use computer techniques to identify what objects in the resulting data fusion are trees, and we can classify that image just like this. And of course, then we can develop a high resolution land cover that tells you not only where the trees are, but where the other types of land cover in the data set are. So one of the really powerful things about this type of data analysis, one is it can be used in all kinds of geographies. This is a clip from some of the work we did recently in Los Angeles City and County, and just wanted to illustrate that this isn't just about neighborhoods and subdivisions. You can use these techniques in other types of landscapes as well. Now, when this really gets powerful is when you mash it up with other shapes. So once you have the land cover established, it's like a cookie cutter. You can take any shape and you can lay it over the image and say how much of this shape is covered by tree canopy and how much of this shape has space in it that could theoretically support a tree. And we normally call that existing and potential or possible tree canopy. So this is something we see in cities all over the country. Most every place has this. This is a parcel layer. So we take the parcel layer for this place that we have the high resolution land cover in, and we throw the parcel layer on top. And based on that, we can classify it by how much existing tree canopy it has and how much possible tree canopy it has, not only over the entire area, but on every single parcel. So if you were looking to have a tree planting program that you were going to do a tree giveaway, for example, you could use this to say, where are the properties where there is the most opportunity to support more tree cover based on the land cover that's there. And you wouldn't want to go knocking on those individual doors, but if there were a higher concentration of opportunity in one neighborhood versus another, that might be one that you target for a tree planting program. There are other types of geographies that people are interested in. This is a land use map, and this can also be used for similar types of analyses. And once you run those analyses, you can come out with different types of data. So this is a part of the work we did for Los Angeles City, and in the top, it has the existing tree canopy in acres. And then in the bottom, it has the percent tree canopy cover by land use. You'll see along the x-axis along the bottom. So this is really helpful. In some ways, if you looked at the bottom row, you would say, wow, protected land use class has the most tree canopy of any land use class, which is really helpful. But if you look at the top bar, you'd see that when you're looking at acres, protected land class is little to none of the acreage in the city. So if you wanted to do a tree canopy program, you want to go where the opportunity is, and the existing tree canopy is in the residential land use class far more than any other, followed by recreational, then right of way. Many of these parcel data that are available have very rich attribute data in them, and they tell all kinds of things about the property. And in a lot of places, one of the things it tells you is when the property was developed and when, you know, the first house was built on it. So this is a correlation between the existing tree canopy and the year built. And as you can see, there is a relationship between when the property was developed and how much tree canopy it has. You would think, you know, you clear the lot, you plant a few little trees and they grow older and get bigger over time and you have more tree canopy. Not what we found in Los Angeles City. You can also look at this according to housing value. And, you know, some of my colleagues have published papers with titles like Trees Grow on Money. And this is, again, another example of how that works. You can see the relationship between home value and existing tree canopy, and the more your home value is worth in this particular place, Los Angeles, the more tree canopy you're likely to have. We can use business analytics to look at some of these data in different ways, and these little squares we see are census blocks, and the size of the square and the intensity of the color is the amount of relative tree canopy that that particular block has. And what this tells us is this is not a misprint, because this is a, you know, a sub zip code geography. We can have multiple blocks with the same name, place name. So you see Brentwood twice, that's not a mistake. What this tells us is, if you look at the two leftmost columns, that represents a really significant amount of the tree canopy in Los Angeles, and it's almost all on private property, and it's in a handful of census blocks. So what that says is, if a very small number of people decided they really didn't want trees anymore and they removed them from their private property, it would have a really outsized impact on Los Angeles tree canopy cover overall. Our client for this case and partner was an NGO in Los Angeles called Tree People, and working along with them was the Center for Urban Resilience at Loyola Marymount University. Great partners. We had a great time working with them on this, and they asked us to prioritize where trees and tree cover should be initiated or enhanced. And so we looked at things like surface temperature, the dependence ratio, which is the oldest and youngest people, the people who are dependent on other people, and also looked at non-white population and median household income to put an equity lens on this analysis, and came up, when we mashed those up with the figure that you see on the right, about the highest and lowest priority areas. And that lowest priority band that you see going east to west across the center of LA city and county is the mountains. One of the things that you can do with these data is change detection. So some people will look at an image in one time, analyze it, look at an image in another time, analyze it, and say the change is the difference that I come up with when I look at the two images. The folks we have been fortunate to work with instead take those two images and they actually pin them together. They overlay them and they map locational change. And the change that is reported is the change that's observed locationally between one time period and another time period. This is a Baltimore tree canopy change map. This is an ArcGIS app that's available on the Tree Baltimore website, but where tree canopy change between 2007 and 2015 was mapped over that period with, as you can see, the light green being gained, the red being loss, and the deep green being no change. So again, using this, you can mash these up with other data and see, why is loss happening? Is it storms? Is it pests? Is it development? Is it some combination of these things? So I hope that was helpful. We're going to talk a little bit about planning for trees in the development process. I've been fortunate to work for a long time in the state of Maryland. It's the only state in the country that has a statewide tree preservation law during the development process called the Forest Conservation Act. And in the Forest Conservation Act, you've got to have two documents. One of them is called a forest stand delineation. It's basically an existing conditions plan that shows the existing forest and trees on site. Trees of a certain size and quality have to be reported and called out individually, and then forest stands have to be called out. And part of that is a tree table, like you'll see here, with all of the trees that meet the criteria depending on where in the state it happens. You have to call out the size of the tree and the species and condition, and whether or not the tree is going to be preserved or removed. And then there's a mitigation scheme if you cross certain thresholds of tree and forest removal. The second document you need is a forest conservation plan, and that is a plan that looks like this. And sorry, part of my window is hiding this there. So you can see here the limit of disturbance, and these are the critical root zones of trees mapped. And if the limit of disturbance of the project crosses the critical root zone of a tree, you've either got to remove it or preserve it. And if you preserve it, you've got to do things like tree preservation measures like we saw at the bottom right. Some jurisdictions do this differently. This is Washington, D.C. Washington, D.C. calls out for the preservation of trees by size, by circumference rather than diameter, which is kind of unusual. And if a tree is 40 inches in circumference or greater, and this is any tree, any lands, that tree is considered a special tree. It's a protected tree. If it's on your site, you cannot remove it unless it's an exempt species, unless it's a hazardous tree as determined by a qualified professional and concurred with by the regulators, or you pay into a mitigation fund. If the tree is a heritage tree, and by that, the definition is it's 100 inches in circumference or greater, that tree can only be removed if it's hazardous. You cannot buy your way out of that one. You've got to work around that tree if it's on your site. So this is an example of a plan. You might not be able to see these. It's kind of small. There are trees here in numbers in red all along the property line. There were 3 regulated trees here. There's actually a heritage tree out here in the right of way. You see this giant critical root zone delineation out here. That tree was not going to come down. It was a street tree as well as a heritage tree, so it was doubly protected. So the developer had to protect that tree. These trees along the property line were all special trees. So here we did a industry standard tree risk assessment, called out the trees, what their classification was as regulated trees, species, what we recommended be done with them. We gave the industry standard risk assessment, probability times consequences equals risk. And again, according to the industry standard, if you do a risk assessment, you're supposed to recommend risk mitigation and opine on post mitigation risk. So the post mitigation risk for the street tree was low. It was low to begin with. For this tree, it went from moderate to low again. This tree was high. It went to NA because the mitigation recommended was removal. What we were able to do here was get the limit of disturbance moved on site to accommodate these 2 special trees. When we went back and forth, the developer said, you know, I did my report and I said, you've got to you know, if you can't move the limit of disturbance, these trees have to come out. Well, they said, well, go ahead and move it. I said, I'm not an engineer. I don't know what needs to be done to meet grade on this site. That's not a call I can make, but I can say that if you can move the limit of disturbance as far away from the critical root zones of these trees as possible, they can be preserved. If you've got to go to the property line, there's about 50% of the CRZ of these trees that are going to come out, and they've got to be then removed. So fortunately, they were able to move the limited disturbance, create more volume for those trees to preserve roots. This tree, unfortunately, they were not able to do that. This was a double leader tree between two structures. It was not a good place for that tree, and they had to come out on that one. So when we're preserving trees, there's a few stress reduction measures many of you are familiar with. One of them is air spading, a supersonic air knife you see on the left. High-powered air blows down. Our specification that we see is normally 18 to 24 inches. Once the trench is created, then we go by hand and we root prune along the limit of disturbance. And the idea there is you want to separate the tree that's being retained from the grading activity. If the heavy equipment comes in and just begins pulling roots, you can do damage to the root system of the tree later. So by separating that tree from the grading with a clean, sharp knife before the grading begins, we hope to be able to encourage tree health and preserve that tree in a proper way. This is an unusual site on this job on the left. We actually had to preserve trees within the limit of disturbance because it was going to be a play area for kids and they wanted those trees. So we had some kind of alternative tree protection measures using 2-bys with sandbags at the base to protect the root flares. This is sometimes called tree armor, but different than you would see in a traditional situation like you see on the edge where there's root pruning along the edge of the disturbance and then tree protection fencing there. And you can see that occurring here. Here the silt fence is also the tree protection line, and the root pruning is occurring along the LOD. Here we had to use heavy equipment rather than a root spade because, an air spade, I'm sorry, because the soils were very heavy and wet and just couldn't get through it with an air spade. There's a tool I'm not sure you're familiar with, but I wanted to mention it. We were really excited to get one of these this year. It's called Tree Radar. It is the only totally non-invasive tree diagnostic tool. It is also one of the few that can be used to assess both trunks and roots, and you see that occurring in the image that you have here in the graphic. You hold the antenna up and you can scan it around the tree part, and it will give you a readout like you see at the bottom of this image. Here you can see the trunk being scanned, and here's what the printout looks like, the data from Tree Radar. These are root scans. You can scan around the tree, and these are some of the outputs that you get with a root scan to be able to know. We have these kind of conceptual models of root systems, that critical root zone and structural root zone and things like that, but we know the trees don't read the books and that roots grow meristematically along a path of least resistance. So sometimes trees don't grow in a circle like a dinner plate. They go where they can go depending on the soils available on site. So we're really excited about this capability. This is a great tool. There's a lot of useful information about it on the Tree Radar website. One of them is a video. Smithsonian Institution Horticulture had some Tree Radar scans a few years ago on some of their properties, and they were so excited about this tool, they had a video made displaying its capabilities at their own expense, which was great. I also wanted to mention iTree. I think probably most of you are familiar with iTree, and wanted to show some of the ways that it can be used. This is a part of the university system in Connecticut. And our client had this tree population, and they were concerned about it for a couple of reasons. One was there's a significant ash component in the population, and they're concerned about emerald ash borer. Another concern is some planned development in this area. So what we did was we inventoried the trees. We ran it through iTree Forecast, which can tell you what your canopy will look like over time with a given population of trees. And we could tell them what their tree cover would be on the top with no action over the study period, and then what planting levels they would need to take on an annual basis to basically maintain their canopy cover over a given time period. And we were able to do that with and without ash trees being part of the tree population based on the model. So a lot of capabilities and flexibility with iTree. Great tool for tree planting. I've got one more piece. I've got a question in here. Has tree radar been used to check quality of nursery stock in container trees? Not to my knowledge. The antenna that we use is not that fine. There are antennas that can both look deeper than ours goes down. It's made for use in, landscape areas, and it can go down about 36 inches. There are smaller antennas that can be used for branches, and there are larger antennas that can go down deeper into the soil. I've known practitioners to use the smaller antenna to look at tree branches, because the size antenna that we use can do trunks but not branches. I have not heard of anybody using it for that purpose, but it's an interesting question. Thank you. The last thing I wanted to touch on is using wood. So a little bit of our experience in Baltimore with the Baltimore Wood Project, and I will follow up with some materials from this project, but you may or may not know that there is more wood, and that is construction and demolition wood, yard waste, and wood from tree removals thrown away, landfilled in the United States than is harvested from the national forests of the United States. The volume of woody biomass is greater, and it's just thrown away. So we thought there's probably better things we could do with that. In Baltimore, where we do a great deal of work, there's a huge problem with vacancy and abandonment. So there's a lot of materials. The housing stock is row homes. So basically a block is one giant house that's all connected. So there's a high density of materials in a small area. There's big problems with unemployment and poverty. Big problems with public outlays for incarceration in the city. Really high levels of incarceration in certain neighborhoods in the city. There's very disparately distributed tree canopy cover in the city. And there is a legacy of redlining, as there is unfortunately in many cities in the United States. Baltimore is certainly no exception. So at the Forest Service Baltimore Field Station, we started thinking about how can we put these problems and opportunities together. And we had some great partners to work with in an NGO called Humanum and in Baltimore City Department of Recreation and Parks. This is the conceptual model that we developed as we learned over time. And what we found was many people are opportunistic with their green waste. They cut trees down. It's a byproduct of what they do. They just get rid of it wherever they can as quickly and cheaply as possible. We found people that make things out of wood, bowl turners, furniture makers. They might use urban wood, but they might get it catch as catch can. They don't really have a system, or there's no place they can reliably go to get that material. And then consumers, they buy things if they see it, they like it, but there really isn't a overall market for these materials. And we found that if we could be strategic and help people to count the inventory of potential materials and people in the supply chain, and if we could salvage those materials after they were generated and sort them for use type, everything isn't going to be a live edge slab table. but some will be tables, and some will be firewood, and some will be chips, and some will be other types of, some will be pallet material. But being able to sort by quantity and quality and species will help improve the market opportunity for the material. And what we found, again, is there's a little bit of high quality material, and there's an awful lot of low quality material. So being able to have a place for everything is really important if you're going to have an urban wood operation, because there's a high variability if you look at the dollars per ton for the different products that you get from wood waste. The U.S. Forest Service has a urban forest inventory and analysis program. It's the Forest Service has done an inventory of the nation's trees, a census of the nation's trees since the 30s. And beginning in 2014, they began to expand that into cities for the first time. So we're really excited about this expansion, and it will let us know a lot more about urban woody biomass stocks in cities for the first time. This is our partners at Humanum had a project called Details Deconstruction. And again, they had a contract to deconstruct rather than demolish row homes in Baltimore and create jobs for people with barriers to employment. That was largely folks who had a history of addiction or time in the criminal justice system, or both. And Details Deconstruction was able to create hundreds of jobs and put people back online to employment and property ownership and a lot of great things. Unfortunately, we just found out in the last week or two that due to the market crash related to COVID-19, that Details Deconstruction has had to close its doors, which is heartbreaking to us in Baltimore. Again, Salvaging Materials. This is Sean Preston with me and Lauren Marshall from the U.S. Forest Service. Sean is the yard master at Baltimore's Camp Small, and he took a giant pile of wood waste and made it into a sort yard instead of a dump yard, and began to sell logs, sell compost, sell chips, and make this thing a net zero waste facility that is sustainable. It pays for itself because he's able to sort the materials and find markets for them. At the top, that's Max Pollock from Details Deconstruction, and we see a deconstruction site in operation. Again, salvaging and sorting both deconstruction material and wood waste from tree care operations. And then once you have that material, there's some processing that can be done. Sometimes people want that material as is, but sometimes they want additional finishing on it. So this is at Brick and Board, an affiliated company of Humanum, and they're able to put some extra finishing on that to meet spec for different folks in the architectural community. Here's Brick and Board. That's the outside of their facility. They've got a beautiful website. They do a fantastic job with recovered and reclaimed materials. They don't do a lot of retail. They mostly scale up to for the architectural and design community. So we were really fortunate to have a company called Room and Board, a maker of fine furniture from the upper Midwest, come and visit us in Baltimore, and they were really excited about what we were doing and made a line of furniture from wood reclaimed from Baltimore row homes that is doing fantastically well. Based on that relationship, when the company I work for, Save-A-Tree, opened an office in Detroit, I was able to connect Room and Board with Live Edge Detroit, which is associated with Save-A-Tree's Detroit office, and Save-A-Tree's tree removals. A certain number of them go to Live Edge Detroit, and some of those materials are made to products that now are being sold by Room and Board. So really exciting that Room and Board is getting involved with both deconstruction, urban wood, and what we call fresh cut wood from tree removals. On the bottom left, that's me and Jeff Carroll from Humanum. We had a great opportunity to visit Taylor Guitars a couple of years back. Taylor Guitars was very interested in shortening their supply chains and looking at more sustainable supplies of wood, and had some conversations about urban wood. And if you go to the recent issue of Rolling Stone magazine, you will see Rolling Stone featuring Taylor Guitars' new urban ash guitar made by Taylor Guitars. It's one of their custom series, and there's a great article in there about Bob Taylor and his team and their journey to decide to move forward with a line of guitars made from urban wood recovered from the waste stream. As we had conversations with a number of people, we thought there's some learning here that other people may be interested in. So we had a few iterations of something called the Urban Wood Academy. And I think Kevin attended one of those events in Baltimore. We had people from all over the country: California, Idaho, Oklahoma, Georgia, Mississippi, many states around the country, but tried to convey how to think about a system and a network for urban wood generation, recovery, and market supply chains. We also had some great partners who helped with the economics of such ventures. Quantified Ventures is a social impact investing firm, and they wrote a couple of reports based on studying what was occurring in Baltimore. They did one report based on the economic feasibility of doing building deconstruction. Another one was on doing a sort yard with fresh cut material and what the economics of that were. They also wrote up what that would look like if social impact bonds were involved, how it would work, and what the expected outcomes and outputs would be. And so by identifying entities that would benefit from participating in this, in other words, entities that would pay, they helped create opportunities for partnerships. And here's the Urban Wood Academy dates and the states where we had people visit us from, and just great opportunities at those events. In wrapping up, a couple of things I wanted to share with you. One is the Baltimore Wood Project website, and I'm going to follow up with an email to attendees to send you some links. I would also note Vibrant Cities Lab. It's a toolkit for urban sustainability. And just out this week is a book that we were happy to, the Baltimore team was happy to put out, called the Urban Wood Workbook, that describes kind of the process of identifying an urban wood supply chain and getting it started. I'll have some links for you on the LA City and County Tree Canopy report, the Tree Radar website, the iTree website, the Urban Wood Workbook, the Baltimore Wood Project, and the Vibrant Cities Lab. And I really enjoyed the opportunity to speak with you today. And I hope that you have some questions, comments, and observations for me now in the time that we have remaining.
Thank you, Mike. So we'll field any questions. Please use the Q&A to submit your questions. We have one here from Adriana. How does the tree radar compare to sonic tomography in terms of accuracy, ability to detect decay within a cross section of a trunk? And do you know how the technology compares in terms of accuracy and cost?
That's a great question. Thanks for that. There is published research on both of these tools, but I'm not aware of any comparing them to each other. Sonic tomography is based on the void, and tree radar is based on the moisture content. So they have a little bit different basic premises. Some folks like one of these tools or the other, and they just like them. I like tree radar. I've known the inventor, Tony Mucciardi, for 20 years. I was involved with him when he was developing the tool, and I've seen its evolution. And one of the things that I really like about it is it's truly non-invasive. Sonic tomography, as you know, you've got to breach the cambium all around the tree to install the sensors, and you don't need to do that with tree radar. Tree radar is an expensive tool. I'm not sure what a sonic tomograph costs, but I know a tree radar unit is expensive, and I believe it's quite a bit more expensive than sonic tomography. So I think it's more a question of the right tool for the job. You know, for me to go in, and if I have a client who's concerned with, you know, butt rot on a tree, if I can scan the trunk and I can scan the roots with one device pretty efficiently, that's really useful to me. I'm not sure that a tomograph is set up quite that way to do that. So I think they're both useful tools, but different applications. I hope that's helpful.
Got another one. Do you know of efforts to adopt the Forest Conservation Act in other states?
I do not. I don't know of any other state that's really tried to do that. And it's interesting. So Maryland is a home rule state. And what happens in some cases is there will be a particular county in the state that will adopt a law. And then it's like the bag ban, like different jurisdictions are adopting bag bans in Maryland. And then soon there's going to be a state bag ban because it'll be present in too many locations for it not to happen. That's kind of how forest conservation worked. It began as a county level effort in Prince George's County, and then it went to adjacent counties, and there was enough interest in it. It bubbled up and became a state law. It was passed in '92, so it's been around for a long time at this point. Despite some fears expressed that it would cause, you know, the market to crash and it would restrict land and no development would occur in the state and everybody's property values would plummet. None of those things have in fact happened. About almost 30 years in at this point. So it's workable. It's workable. And I think that's kind of exciting that that case has been demonstrated.
Got another one that just came in. What do you see as the biggest challenges in preserving trees in cities/towns? Are you optimistic about current efforts to enact tree ordinances or prevent forest fragmentation?
Well, I think one of the biggest challenges is, you know, the need, as we have more people and we need to accommodate them. You know, they need places to do things. It's funny, this recent situation is showing that, you know, in some places they're already beginning to close down some roads and use them for pedestrians and other purposes instead of travel. So, you know, need can kind of be a funny thing. You might think you need something and then you find out you really don't. I'm really encouraged by some of the efforts that I've been involved in. One of them is the Chesapeake Bay Urban Tree Canopy Expert Panel. So under the Clean Water Act, there's something called TMDLs, Total Maximum Daily Loads, and it's a pollution diet. So under the Clean Water Act, jurisdictions get assigned a pollution diet of a regulated pollutant. And they say, you can only have this much of this pollutant or less in your water body or you're in violation and you have to do something to fix it. So there are BMPs that have credits that will let you mitigate against those things and get credit for them. You really don't get a credit, you get a reduction in loads. But for our purposes, let's say it's a credit. So a few years ago, the Chesapeake Bay program, which is the governors of the Bay States and EPA and the mayor of DC, entertained considering urban tree canopy as a BMP. So that means it would be a land cover class, that it would be credited a certain pollution loading rate. So we had ag and we had forest and we had developed. Now we have urban tree canopy. So it considers trees in cities, which is great. And high resolution land cover mapping for the entire Chesapeake Bay watershed was done. 64,000 square miles, sub-meter accuracy. Amazing, amazing effort. But what that does is, that was a baseline measurement. So all the jurisdictions in the Bay will get a land cover loading rate based on that measurement. In 10 years, there'll be a remeasurement. So if those communities don't have mechanisms and programs in place to protect tree cover, to plant new trees, they'll get a higher pollution loading in 10 years. And they'll have to come up with other means to mitigate that pollution loading. Does that make sense? I think it's really exciting because it finally will put some real skin in the game, at least in the Chesapeake Bay, which is huge on the East Coast, for cities to say, look, I have to be intentional about this, or I'm going to have to pay a bunch of money to do stormwater BMPs, so I'm not in violation with EPA or Clean Water Act.
All right. Are there any other questions, anyone? Okay. All right, I'll leave another minute for any other questions. If you think of any after the presentation, you can email me and I can forward it over to Mike. I'd like to thank Mike once again for taking the time to give us this presentation. Thank everyone for attending. Anyone looking to get ISA CEUs, please submit your name and ISA number into the chat. That's how we'll collect those numbers for submission. The next presentation will be in 2 weeks on May 28th. That will be on tree inventories and management plans by Andrew Ullman of Davie Resource Group. Mike, thanks once again.
Thanks very much. Have a great one.
You too.